Greetings. Here again, this is Mr. Glenn of ACT Prep Chicago. Um, Coming to you with part two of the PACT review for the math questions. Part one was numbers 1 through 17, I believe. We'll start this one with question 18 and go to 36. Again, I'm Mr. Glenn, Master Instructor of ACT Prep Chicago. We've been preparing students for the ACT, SAT for 15 plus, almost 20 years now. Direct contact is www.actprepchicago.com, or you can email us at actprepchicago@yahoo.com, or you can call us at 773-474-2540. Without further ado, let's get to the test, the PACT, or I'll show you the website just in case. So this is what you're looking for when you look for us, actprepchicago.com. That's what you're looking for. And also you are looking for the, if you wanted to contact us, you can contact us at this actprepchicago@yahoo.com, or phone number 773-474-2540. Without further ado, let us get started on the remaining questions of the math, part two. So hopefully you can see our screen. Oops, stop sharing. Let's do it there. All right. So number 18, the expression x squared plus 5x minus 6 is equivalent to, this is factoring a quadratic. That's the name of the skill. I like to include the name of the skill just in case you want to do extra practice on it. So essentially what you're doing is you're looking for the factors of 6, or the numbers that multiply to give you 6, or negative 6, but add to give you positive 5. Okay. So what are the factors to give you negative 6? We could do 1 times 6. We can do 2 times 3. Those are pretty much our factors. We'll figure out the sign in a minute. And because we want to get positive 5 when we add the 2, we'll need to do, we can't do 3 plus 2 because that would be 3 plus 2 is 5, but positive 2 times positive 3 would not be negative 6, it would be positive 6. So we have to do positive 6 and negative 5. Because what? Because negative 1 plus 6 is equal to positive 5. That's our middle term. And negative 1 times 6 is equal to negative 6. That's our last term, our C term. Okay? So these are the factors we're going to use. And so we factor that to x minus 1 times x plus 6, which would be choice K. All right. Okay, let's move on to the next one, which is number 19. It says, what is the positive solution to the equation? Why do they ask for positive solution? Because since it is x squared, when you square root, you should get plus or minus, right? I'll show you in just a second. So you write our problem. We're just isolating the variable to solve the equation. This is solving the equation is the topic here. Solving an equation with exponents, you could say, or solving the equation with quadratics, however you do it. So the first thing we do is we want to isolate the x. We get rid of the 16 first. Next to 16 means multiply. The opposite of multiplication is division. We're going to divide both sides by 16. Cancel there. We could, at this point, we could reduce the fraction, but we're not. Why not? Because the denominator is a perfect square. So we're going to leave it as 30 over 16 because we know to get rid of a square, we have to square root it. And we can square root 16, even though we can't square root 30, we can square root 16. So we're going to leave it. If we simplify this, reduce the fraction, what number goes into both 30 and 16 is 2, that would reduce to 15 over 8. Neither 15 nor 8 are perfect squares. 8 has a perfect square in it. However, we'd like to keep it as perfect squares since we know the next step is going to be square rooted to isolate the variable. So we're going to get x by itself. X to the second power, opposite of square is square root. Whatever we do to one side, we do to the other. And we get x is equal to, now because it's x squared, whenever you take the square root when you're solving an equation, not general square roots. If I just do the square root of what? Let's see. If I do the square root of 16, that's just generally 4, right? So if you just do a general square root, you do it. But when you're square rooting to solve an equation, they want you to do plus or minus. So really it's going to be positive, plus or minus means it could be positive or negative. That means you have two solutions. Because the 16 can be square rooted, we're going to leave the top as square root of 30, and we're going to leave the bottom as 4, because the square root of 16 is 4. Okay? So when you have the square root over both numbers, you can separate them individually. I didn't write that out, but you can see that square root of 30 is on top. Maybe I should write it out. I can write it out just so you can see the steps. So when it's a whole one, you can separate them. When both numbers are under the radical, as in this step up here, square root of 30 over 16, we can separate them into two separate. The reason we do that is because 30 is not a perfect square, and 30 does not have perfect squares in it either. So it can't be simplified. So we just do plus or minus the square root of 30. Now, square root of 16 can be simplified. It's 4. We just do 4. We're not solving the equation anymore, so we don't have to worry about the plus or minus. We just assume square root of 16 is positive 4. Okay, but plus or minus means you really have what? Two solutions. You have a positive square root of 30 over 4, and you have a what? A negative square root of 30 over 4. That's plus or minus, okay? And it says, what is the positive solution to the equation? The positive solution would be, okay, so they didn't simplify it. It would be here, right? They didn't simplify it. So they just kept it as kind of like here, right? Yeah. So I guess I solved a little bit too far. You see how they can trick you, though. You see how you get square root of 30, but it's over 16 there. Remember, 16 was radical. It should be radical 16, which is actually 4. So be careful with that. Okay. Next one is number 19. Sorry, number 20. The length of a rectangle is 4 inches longer than the width. A lot of times when you see these, you like to draw a rectangle. A lot of times the length is this, even though it looks like the width. They call this the length usually, and the width. Okay, and the length of the rectangle is 4 inches longer than the width. So I want to draw a length that's longer than the width, right? And so I would say, and then you can write this as an expression too. You can say the length is what, 4 inches longer than the width, which means when we do the width, we add 4. And then this would be the width, right? So we express both of those in terms of width if we wanted to. The perimeter of the rectangle is 28 inches. What is the width of the rectangle in inches? So based on me expressing it that way, that the length is 4 inches longer than the width, and I write like that, I can really, and I know perimeter is equal to what? 2 lengths, which is the top length and the bottom length, and 2 widths. So they write it like 2 length plus 2 width. That's the perimeter of a rectangle. Now we start substituting. We know that P is equal to 28. We know that the length is equal to the W plus 4, and then we just leave W there. Why do we do that? Because now we have an equation with only one variable, which is the W. Before we had an equation with 3 variables, P, L, and W. We were able to substitute for P. If we had just left P 28, we still would have an L and a W. But because we were able to express the length in terms of the width, then we could substitute the length with W plus 4. Now we have an equation with just W's, which means we can now solve it. 28, we're going to distribute first. 2 times the W and 2 times 4, because that's what you do when you have a number on the outside of parentheses. We have 2, whoops, sorry. We have 2 times W is 2W plus 2 times 4 is 8 plus another 2W. Now we're going to combine our like terms, which are what? 2W and 2W, which is 4W. So we're going to come down. We have 28 is equal to what? 4W plus 8. And now we're going to solve a two-step equation, right? We put a line through the equal sign. We get a plus 8. So after adding 8, subtract 8. Okay. And we get what? We get over here, we get 20 is equal to what? 4W. And then we're going to do what? We're going to divide by 4 to get the 4 by itself, because 4 next to means multiply. Opposite multiplication division. So we get that the width is equal to 5. Okay, is that what we wanted? Now we always go back to the question to make sure that's what we wanted, because they may have asked for the length. What's the width of the rectangle in inches? The width is 5. Okay. So now, that's one way to do it. Another way to do it is you could really kind of use the answers, right? So the other way to do it is if the length of the rectangle is 4 inches longer than the width, perimeter of the rectangle is 28, right? So if we had we still would draw a rectangle, or we really wouldn't even need to draw a rectangle because let's assume that they say what the width is, right? So if the width is 5, I don't need to draw my rectangle this one. So if width is 5, then based on our definition, which is when the length of the rectangle is 4 inches longer than the width, then the what? Then the L would be what? The length would be 9, because 9 is 4 inches longer than 5. And then we would do what? The perimeter, which would be what? 2 lengths, not just one, but 2 lengths, which would be in this case 9 plus what? 2W, which would be 2 of the widths, which we assuming is 5. And that would be what? 18 plus 10, which is 28. And that's what they said initially that the perimeter should be. They said if the perimeter is 28, the 28 is equal to 28. So that means that is correct. You could put a what? A check mark on there, right? That's another way you could do it. You could have used the answers, okay? It just so happens that that first one is the correct answer. But let's try one that was wrong, right? So in this case, let's see if what? If W is 7, right? Then that means that if the length is rectangle is 4 inches longer than the width, we would do what? 7 plus 4 to get what? 11. So the L would be 11, okay? And then plugging that into our perimeter formula, we get 2 times L, which is 11, plus 2 times W, which is 7, because it's 2 lengths, top and bottom, and 2 widths, side and side. So we get what? We get 22 plus 14, which is equal to 36. And that is not equal to the 28 that they originally gave us. Therefore, what? This one would not work. And you will see that if you try it with G, H, J, K, they also, I'm sorry, we tried it with G. If you try it with H, J, and K, they also would not work. Moving right along. Number 21. I remember this one. I was helping a student with this one. I just kind of counted this one. It says each small square on the grid shown below has a side length of 1, right? Each vertex of the shaded region lies on the vertex of a small circle. So what is the area and square meters of the shaded region? I just counted. I'm sure there's another way to do that where you could do like the area of the whole thing and then minus the pieces out, right? You could probably do it that way. I could certain shapes to each piece, or you can break it down, but I just counted. I counted. That's that. I felt like that was the easiest way. So we got a full. I counted the full ones first. 1, 2, 3, right? 4, 5, 6, 7, 8. These are full. 9, 10, 11, 12, 13. Because each square represents a shaded region. 14. Right? So we have 14, looks like pretty much full squares. Then we can piece them together with pieces that don't work. Well, the pieces that look like they can, if you put them together, they might make a full one. So if, for instance, if we put these two halves together, right, this and this, we get a whole, right? So then you can count from there. So far we counted what, 14 holes. Then we put two halves together to make another whole. Let's see if we can do some more of those. Put pieces together to make holes, and you got to make sure they kind of go together. Okay, so all of these are halves if you see how this is going. So that's a half, that's a half, that's another whole. So I'm gonna add a 1, right? And then that's a what? This is a half, and this is another half, right? And you see how they split in the boxes in half? So that's another whole. 2 halves equal a whole. Just trying to see if I see anything else. Oh, if you do this piece here, that's the same as this piece here, right? Those two pieces are the same, which means that the last piece and this piece could make a whole as well. See that? But so that's another whole, right? Let's see, same with these pieces. If you take this piece and you put it here in this empty spot, it would make a whole square, right? So then that means that what this little corner here and this piece together, if we put them together, if you flip this piece up there, that's going to be in that triangle to make a whole square. So that would be another hole with those two. Same with this one. Same with these two. So this one and then that top piece flip is that. So that's another whole one. So I'm just shading as we go. If you look at okay, then this little corner here and this piece there, right? If you take that corner and put it there, that's gonna be a hole. So that's another one. Okay. I'm just marking them off as we go. Looks like this one, maybe this one. And there's these rough estimates. That's another hole, right? And maybe these two on the outside. We'll put those two together. Boom, boom. That's another hole. So it looks like we got everyone accounted for, and we were able to put certain small ones together in the whole one. So we got what, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that's 23 squares. And because they said that each side length is 1 centimeter, that means each square is 1 centimeter square, right? So it says, well, what is the area in square centimeters, right? Because each square, again, each square is 1 centimeter by 1 centimeter. You follow? So that's 1 centimeter by 1 centimeter, which is what? One times one is 1 centimeter squared. And that's square centimeters. That's what you use for area. So essentially, how many full squares do we have? So we counted 23. Any questions? Can't ask questions because I'm doing a video. All right, hopefully you get that. Let's move right along. And if you have any questions or comments, feel free to comment. I'll try to respond back as soon as I possibly can. Get a little drink quickly, refresh. We can get through. All right, this says, what is the slope of line HM shown in standard XY coordinate plane? Slope is rise over run. We want to get to 2 points. So I want to go from this point to this point. And I go down, up, or left and right. So I'm going to go down 1, 2, 3. So that's down 3. That means my top number of my slope is -3, right? The slope is equal to what? Rise, how you go up and down, and run, how you go left and across. So my slope is what? Put it there. So I went down 3. It was negative because I went down, not up. And then from there, I go in over what? 1, 2, right? And I can use these units to count up there. So that's to the right 2, that's positive. So my slope is -3/2. All right, moving on. Oh yeah, this was a good one. An equilateral triangle is inscribed in a circle, and the smallest circle is inscribed in the triangle. As shown in the figure below, if the radius of the smallest circle is 3 inches, what is the radius in inches of the large circle? So this one I had to refresh on some circle skills. Okay, we have a center of the circle here. So we can draw the radius a lot of ways. I'm going to draw the radius here. Okay. But what I found out is the radius is also part of a median. So let's draw a median segment here. And then remember, this is median of an equilateral triangle. So a median segment would be what? From a vertex to the opposite side, but bisecting the opposite side. So it cuts it in half. So it means that would be equal to that. Basically being a median, right? And if we did a median from this vertex to the opposite side, right, and cut it in half, that would be there. And then the median from this vertex to the opposite side would also be there. So these are all medians, and medians intersect at a point called the centroid. And what is the centroid? The centroid is the center, well, let's say the center where medians meet. But what does it do? The centroid does what? The centroid divides medians into what? 2-to-1 ratio, right? Okay. That means my biggest part is going to be what? Twice as big as my what? Small. Okay. Now, again, if you look at these are medians, but also this part of the median from the circle, well, first of all, the thing is me that also you got to take into consideration that the centroid of a equilateral triangle is also the center of the circle that it inscribes. So that's a theory. So if you have the centroid of an equilateral triangle, it also, this is the centroid here, it also is the center of the circle that the equilateral triangle inscribes. So if equilateral triangle inscribes a circle, then the centroid is also the center of the circle. That's important to know because now, if the centroid is also center of the circle, then from the center to here is called the radius. So we know these are 3. And this is 3, and this is 3, because these are all radii. But the other 3s aren't as important because I just want to get to this little median here. So if this is 3, we know the medians are in a ratio of what? 2-to-1, which means that whatever the small piece of the median is, the larger piece has to be twice that. So this would be 6. And then you should also see that this is the radius of the larger circle because it goes from center to any point on the circle. All right. So the answer is 6. Hopefully you guys got that. The 2-to-1 ratio is when you have the centroid, right? The centroid, which is that piece here, is going to divide it to 2-to-1. So this is going to be 1, this piece, and this is going to be twice, which means that the higher piece or the bigger looking piece of the median, when it crosses to make a centroid, that bigger piece is double the smaller piece. I think I made that clear. All right, 24 says, given the functions f and g defined by f of x equals x plus 3 and g of x equals x for what the value. So these are called composite functions, right? So the easy thing to do is work on the inside of the function first in this case, so to get g of 1. So g of 1 is, all you're doing is you substitute everywhere there's the x value, you plug it in 1. So g of 1 is, once you see, because g of x was given x squared plus 1. So g of 1 is, I replace the x with 1 every time I see it. So then 1 squared is 1 plus 1 is 2. So g of 1 is actually 2. Okay. So then when we do this substituting, when we have f of what? G of 1. Well, since the g of f of 1 is equal to 2, instead of putting g of f of 1, we could actually put a 2 there. Because that's what g of 1 is equal to. It's equal to 2. And now we do our what? We do our f of x function, which was x plus 3, right? So if f of x was x plus 3, then f of 2 would be what? Replace x with 2 every time, so 2 plus 3 equals 5, which is any questions? Oh no, I'm so used to asking any questions. Okay, let's go for 25. In the diagram below, B, F, and H are on segment segment AE, and BF respectively. So B is on AC, F, that's what respectively means in the orders, right? F is on AE, and BF, oh no, this is BF and H are on that BF as well. And that this and the GH is perpendicular to BF, which they have it marked here with the 90-degree angle. That's perpendicular. The area of square ABGF, ABGF is 1/4 the area of square ACDE. So that makes sense because basically if you take this square and you make four of them, right? This is one, this is two, this is three, this is four, right? So when they say that the area of ABG, ABGF is one-fourth the area of A, that actually makes sense, okay, based on the diagram. So now it says the area of triangle FGH is what fraction of the area of ACDE? So when we look at what? When we look at the triangle, when we look at the shape, right? Um, we look at this triangle and we ask him what fraction of the area of the whole thing. So what piece does this represent if we were to make equal pieces of this throughout the figure is essentially what it's asking, right? That's what it's asking. So that piece, how does that represent? So we got the one that's shaded already. We'd have another one here. We'd have another one there. And then we'd have another one there. And we do that for all of them, right? So we could, from this figure, we're going to be able to make four squares, right? So, I mean, so from this figure, we can make four triangles each. So this one has four we shaded, this one's four, this one's four, this is four. So then that means that what? Our possible number of triangles would be 16 for the whole thing, right? So the area of FGH, no, what is the H? H is in the middle right there. FGH, which is pretty much what? This triangle here, that's FGH. What fraction of the area of ACDE, the whole thing? So it takes one of those triangles, right? Out of how many could they make? 16. Do you get that? Because it's four for each one. Okay? It's four triangles for each small square, and then there are four small squares. I mean, there's 16 total triangles that are the same size as FGH. So they say the area of FGH, which is 1 out of 16, is what fraction of the area of ACDE, but that's the same thing, 1 out of 16. All right. Next is 26. All right. Another drink here. Royce plans to construct a triangular flower bed on the corner of his property, where a sidewalk forms a right angle. The flower bed and the lengths and feet of two of the sides are shown in the figure below. The flower bed will be enclosed by a garden fence that is set up along its entire perimeter to the nearest foot. How many feet of garden fence will enclose the flower bed? So essentially, it's asking us what? How it's asking us to add all the sides up. So you got four, you have six, and then this side is that. Because you got to, if you want to completely, what do they say? Flower bed will be enclosed by a garden fence. So enclose it, right? That means we got to close it in, right? All right. So how do we get this? Well, when we have, and it says to the nearest foot, so it might be a decimal. When we have, so our basically our feet around is our what? It's our perimeter of the triangle, right? That's what they're asking us. Basically, where's the perimeter of this triangle? Okay, well, to get that, we got to do what? We have to do when we have two sides of the right triangle, we need third, we do Pythagorean theorem. So you got 4 squared plus 6 squared equals C squared. You got 16 plus 36 equals C squared. You got 52 C squared. And then if you square root it, and you simplify 52, you get what? I think it's 4 times 13. It would be 2 radical 13. And it would be plus or minus, but since we're dealing with length of a side, it won't be plus or minus. Right now, because it said to the nearest foot, right, we're going to have to do what? We're going to have to walk. Wait, let me see. We have to multiply the the decimals. I mean the radical to get a decimal. So we got 2 times square root of 3 equals 3 point what? 3.46. So the perimeter would be what? 6 plus 4 plus 3.46. Okay. Which would be close to what? 13.46, which is closest to what? Closest to 14. All right. Hopefully that is because it said how many garden fence will enclose it. So we're looking for the garden fence that encloses it, which is the perimeter. Okay. All right. With number 27, it says angle JKL, which we see there is shown below with the given lengths and coordinate units. What is the measure of angle JKL in radians? So you just have to know the conversion of degrees to radians. So you do 120 degrees times pi over 180. That's pi over 180 goes from degrees to radians. If it were radians to degrees, it would be times what? 180 over pi. If it were radians to degrees, right? But because it's degrees to radians, we do times pi over 180. Hopefully you got that. They flip it when they want to take what? Radians to pi to degrees to radians, or they just want to leave it radians. Okay. All right, so we got 120 times what? 120 pi over 180. Whoops, that's 120. So the rule is if you divide it on top, if they both end in zero, you can cancel them out, which makes our math easier, right? So now we have 12 pi over 18. That's much better than 120 over 180. And then divide both 12 and 18. Now we can reduce this fraction. Divide both of these by 2, we get 6 over 9 divided by 3. Oh, we should have divided it by 6. That's what we should have did. So we get 12 divided by 6, we get 6 pi. 18 divided by 6. No, 12 divided by 6, we get 2. We get 2. And then 18 divided by 6, we get 3. So that is, I almost already like my nephew. He used to like to do work on his work when he was younger. He used to like to draw his pencil all the way around, all the way over here, all the way over till he circled the right answer. So I feel like I was doing that with him. I always felt like I was just doing that now, but anyway. All right, so I remember the difference too. This is not the same because pi on the bottom is divided by pi. Pi on top means multiply divided by 2. Right, and so we're not dividing. In this case, we should just be multiplying. So don't let that get you either. Okay. Next up, which of the following expressions is equal to? So we don't want to square root in the denominator, so we have to do what you call rationalize the denominator. So we have 3 over 4 minus radical 5. Rationalize the denominator is when your denominator is separated by addition or subtraction signs, which it is here, right? If it were just one denominator, we could deal with that a lot easier. All right, so what do we do? To rationalize the denominator, we got to multiply. We got to do a lot of flow for this. We have to multiply by they call it the complex conjugate, or the not complex conjugate, but the conjugate, right? So we took the bottom term and we multiplied by the same, almost similar expression, same numbers, different sign that we have. So then this is going to be just what? This would be 3 times what? 4 plus radical 5. Here you had to FOIL it, so you would get what? You would get 16, right? And then you would do what? You would get 16, then you would do plus 4 radical 5 minus 4 radical 5, that cancels, right? Or I'll write it out too. Plus 4 times radical 5 minus 4 times radical 5. And then radical 5 times radical 5 is minus 5. Okay. Now these two will do what? Those two are going to cancel. Boom, boom. Because that's plus 4 radical 5 minus 4 radical 5. And we'll be left with, and we could distribute the top 3 times 4 is 12 plus 3 times radical 5 is 3 radical 5. All I did was distribute the 3 to both. And that's going to be over 16 minus 5, which is actually 11. And I don't think you can reduce that anymore. You cannot. And so that is the same as number what? That is okay. All right. 29, a health club surveyed 175 members about which types of equipment they had used in the past month. Of the 175 members, 117 had used treadmills, 89 had used stationary bike, and 52 had used both types of equipment. Some members had used neither type of equipment. Other than how many had used treadmills, stationary bikes, or both. So if we did a Venn diagram of this, that might help you. A Venn diagram, and then we draw what, our 2 circles. The circle, right? And so this circle could represent what? People who use the treadmill, the same. This one could help represent people who use the stationary bikes. So 175 total. 117 had used treadmills, 89 had used stationary bikes, and 53 had used both. That 53, we can't count twice, right? So both would be here, 53. So that's people who rode the treadmill and the stationary bike. It would be in the middle, it would be where they intersect. But alone, we would have to subtract. So we would have to do what? We'd have to do 117 minus what? 53. And that would give us how many people did what? Which is 64. I mean, 64 only rode the treadmill. If we do 89 minus 53, we get 36. So that means 36 people only use stationary bikes. You follow? All right. So some members had used neither type of equipment. That means if we add these up, 64 plus 36, that's 100, 153. If we take that from 175, right? We'll call that the null set, right? 153, 175, that's 22. So that's 22 students who did neither, right? This is your 22 could go here, right? It's in that corner. I mean, it's not going to be in either box. It's in the sample space. It's just part of the 75 originally. So now let's ask the other, what's that members? How many use stationary bikes? How many use treadmill, stationary bikes, or both? So that's just how many people use treadmills would be 64 alone would be your treadmills. Plus your stationary bikes alone would be what? It would be 36. And then the people who use both, right? So people who use both, right, which is the 53. And then when you add those up, whoops, I meant 53, yeah. And when you add those up, 36 plus, wait, that'd be, yeah, 36 plus, that's 153. Did I add up before? Oh yeah, I added up before. Yeah. The 153 members, they had either used treadmill, stationary bikes, or both. You could have taken that from the null set too. It was 175 minus, well, you had to add up. Okay, dokie. Wrapping it up. We are on number 30. For the right triangle, triangle ABC, sine of A is 2 over 3. Let's write that out. So we have a right triangle. We're going to make this A. We're going to say sine of A. Sine is opposite over what? Hypotenuse. So we're going to say that sine of A equals 2 over 3. That means if sine is opposite over hypotenuse and it's equal to 2 over 3, that means the opposite side is 2 and the hypotenuse is 3. Okay, that's what that's saying. Okay, opposite angle A is here. This is, if we look at angle A, this is opposite. This side is opposite based on angle A. This side is adjacent. This side is the hypotenuse. If you're looking at angle A. If we moved angle A here, it would change. This would be opposite, it would be adjacent. Hypotenuse would still be. All right, the question though asks is what is the cosine of A? So the question says, so now we got sine. What is the cosine of angle A? Okay. Now, what is the cosine function? So the cosine of an angle, this should have been sine of angle A2, by the way. Sine of angle A. The cosine of an angle, we know is the what? It is the adjacent over the hypotenuse. So do we have the side adjacent? No, we don't have this side here. So we got to do some what? We got to do side work to get there. So how do we do that? With a Pythagorean Pythagorean theorem. So we have 2 squared plus we don't know what this is called. We call it b squared. This is the Griselda branches. 2 squared plus 3 squared equals now 2 squared plus b squared equals 3 squared. 2 squared is 4 plus b squared equals 9. We're going to subtract 4 from both sides. We get b squared is equal to 5. We're going to square root both sides. We get b is equal to plus or minus 5, but because, plus or minus square root of 5. But because we're dealing with side lengths, it's going to be just square root of 5. We're going to leave it like that. We're not going to, no negative, because it can't be negative, and we're not going to reduce it, because if you've got answers, they have square root of 5. So now the adjacent over hypotenuse, adjacent is square root of 5, hypotenuse is 3. Any questions on how we got that? I don't know why I'm asking any questions like I'm talking to a student. I am talking to you guys online or whoever's watching this video, but yeah. All right. Given that I squared equals -1 and k is a positive integer, what is the value of I to the power of 4k plus 2? Okay, and they say I squared is -1 and k is a positive integer. I feel like I did this one before for a student. I think if you let k equal any, so we're going to just let k equal positive integers. So we start off, let's let k equal a positive integer. Right, let's let k equal, I don't like use, I don't usually like to use like 1 as 0 1. So let's use 2, right? And it's going to be positive 2, right? So when k is 2, let's see what's this week. So we got 4 times what? 2 plus 2, which is equal to what? 8 plus 2 is 10. And then it says what? It says I squared is equal to -1. That means we need to express this in terms of I squared. So this would be what I squared. And then when you take one root to another, it's like that. So we can write I to the 10th as what? I squared to the 5th. Why did we do that? Because they gave us what I squared equals. So I squared is just equal to 1. And then 1 to the 5th power is just 1. So that's what happens when k is equal to when k is equal to 2. Okay, let's find out. Let's find out what happens when k is equal to 3, because they say k is a positive integer. So when k is equal to 3, we have I, and we have what? 4 times 3 plus 2, which is I to the 12 plus 2 is 14. All right, so now what do? We want to express it in terms of I squared, so we're going to do what? 14 is I squared to the 7th, because when we take one exponent to another, we multiply. So 14 I squared to 7, we know I squared is equal to negative 1, so that's going to be what? Whoops, what did I do? Whoops, over here it should have been I squared equals negative 1. So that should, whoops. I squared is supposed to equal negative 1. Whoops. And negative 1 to the 5th is negative 1. Because any number to an I powers itself. Negative 1 to the 5th is negative 1 to negative 1 to negative 1 to negative 1 and negative 1. If you take a negative to an even power, it's going to be positive. If you take a negative to an odd power, it's going to be negative. Okay, so I squared was negative 1. Negative 1 to the 5th would be negative 1. Let's see what happens when this here. So this is I14 is I squared to the 7th, because when you raise one power to another, that's when you multiply 2 times 7. So we said I squared was equal to negative 1. Negative 1 to the 7th is, again, negative 1. Anytime you have a base and you take it to odd power, you get what you had, whether it's positive or negative. Now, if it was an even power, it eliminates negative. For instance, if we have what? Negative 1 to the 4th, that's going to be positive 1. Do you see how that's negative 1 to an even power? So it makes it positive. Same thing with what? If we do negative 1 to the, I don't know, we can just make up something. Well, we just square so you can see it. That's 1. So you see how those are even powers. 2 and 4, they turn that negative positive. But the odd powers, they keep it the same. To the 5th, to the 7th, you go on and on. So what you see the pattern is that these two are giving you what? Are giving you values of negative 1. So that must be the answer we're looking for. All right, got a couple more left. A committee will be selected from a group of 12 women and 18 men. The committee will consist of 5 women and 5 men, which are the following expressions give the number of different committees that could be selected. So this is dealing with, if you want to know the topic, this is dealing with what? This is dealing with permutations. I really want to write it out. This is dealing with what? Permutations or what? Or combinations. Okay, and with permutations, we say the order matters. So what do we mean by that? The order matters. Well, meaning that you can't just pick, for instance, if you had a permutation of 12 women, no, if you're picking out of 12 women and you want how many permutations of 5, it wouldn't just be how many groups of 5 you take out, but how they're ordered as well, because the order matters. So if you had, let's say you had 3 letters, A, B, C. A, B, C, if I took out A and B, that would be one combination. But if I ask how many permutations that was, it would be A, B, and then you can switch the word around. You get that? So a combination is just whatever number is pulling out, right? So the letters A, B, C, we can have 3 combinations. We can have A, B, we can have B, C, or we can have what? Or we can have A, C. Those 3 letters, we got 3 combinations. However, we have 6 permutations, right? Because when we pull out the AB, it's not just AB, it's BA, because the order matters. Whichever one you put it in matters. So that's what happens when the order matters. And when does order matter? When you're doing this kind of likelihood with first place winning, second place, third place, right? Or you're doing impossible combinations and you're doing offices, right? You can put different people in the offices. Like, let's say you had student A, student B, student C. That's one combination of students, but then A could be president, B could be vice president, C could be treasurer, or B could be president, C could be vice president, A could be treasurer, so forth and so on. So permutations are when not only do you pull a combination out, but then you could order it in several different ways. So you're always going to have more permutations than combinations. Hope you get that. In this case, we're dealing with what? We're dealing with combinations. Why? Because the order doesn't really matter. We're just selecting a group of what, 12 women and 18 men, and out of the 12 women, we need five of them, and out of the 18, we need five, right? So this is combination, which is your C, right? The answer is K because you take 12 women out of five. You're taking five women out of 12, but the way they write the combination is you put the total here and then the number you want there. So it'd be 12 combination five. So whenever you see 12 combination five, you're saying I got 12 total objects. I want to pull out five. How many different ways can I pull out five? So likely probable outcomes, right? That's what that's saying. Now, if it were permutation choice G, you would be pulling out of 12 women, you'd be pulling out five, but then you also have to say how many ways can they hold office? So out of those five women, which ones could be vice president, president, and then switching those orders around to different people creates a different permutations. Okay, hopefully you got that. All right, let's move on. But that one was dealing with permutation combinations, and it also was dealing with possible outcomes. All right, 33, a container is 1/8 full of water. After 10 cups of water are added, the container is 3/4 full. What is the volume of the container in cups? So if we have a cup, okay, and we say the cup is 1/8 full of water, okay? And then after 10 cups of water are added, now it's 3/4. So this is the 3/4 line. And we're not saying it was empty when you got it. We're saying it was 1/8 full of water. Okay. So then after we add 10 cups to the 1/8, right? We added this 3/4 to the 1/8. What happens? The 10 cups of, no, after we added 10 cups of water, the container is 3/4 full. Okay, so what I'm going to do is, but 3/4 is from here all the way to the what? To the bottom, not to where the 1/8 started. So I want to know what fraction was added. I know 10 cups was added, but what fraction is that? So I got to do the 3/4 minus the 1/8 because that's going to get me this gap here, right? So when I do 3/4 minus 1/8, which is actually 2/4, right? I get one, whoops, not 2/4, 2/8. Wait, no, what did I do? Sorry, I'm supposed to be doing 3/4 minus 1/8. Sorry, 3/4 minus 1/8, but 3/4 is 6/8, right? So 6/8 minus 1/8 would be 5/8. So the amount of water that you put in was 5/8. This water also represented 10 cups. That's what you poured in. So basically the sentence becomes what? 10 cups is 5/8 of the whole or the full amount of cup, right? Do you see that? So 10 is 5/8 of the volume of the cup. This one we can turn into an equation. 10 equals 5/8 of means multiply the volume of the cup, we'll say B. Okay. And then how do we solve this? Well, we can divide by 5/8 or we can multiply by the reciprocal when dealing with fractions, 8/5. That's just cancel, whatever you want to do for the other. So we get what? We get that V is equal to, we cross cancel, that's 1, that's 2, so that's 16. So the volume of the whole container was 16 because when we added 10 cups, that filled up 5/8 of the container. All right. How many more we got? Three more, I think. So we go to 36. Four congruent semicircles touch only at their corners as shown in the figure below. If the path from A to B along the diameters, let's trace that path. A to be along diameter. So this is a diameter. Diameter is from one end of the circle to the other through the center. So this is, but it goes to the center. This is a diameter, this is a diameter, that's a diameter, and that's a diameter. So we've got 4 routes to go. All right. If the path from A to B along the diameter of the semicircle is 100. Now remember, they say those are congruent what? Semicircles too. So that means that what? If they were congruent, that means if we do 100 divided by how many do we have? We have what? We have 4 diameters. 100 divided by 4 would be what? 25. Why can't we just divide by 4? Because it says they were congruent semicircles, which means they would have the what? Same dimensions. Okay. Then it says, how many centimeters long is the path from B back to A along the arcs of these semicircles? So each one of these is 25, which is the diameter. Okay. Now the arc, how long the arc of the semicircles is the circumference. So semicircle is 100 centimeters long. How many centimeters long is the path from B to A along the arcs? If you look at the arcs, right? If we look at the arcs, that's from here along that would be boom, 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 boom. But since these got the same dimensions, right? Since these have the same dimensions, then each of those arcs is the same. But if you put 2 arcs together, you really get the circumference of the circle. Hopefully you guys can see that. If we put this arc with that arc, we get a full circle circumference. So we do circumference equals, and the diameter is 25. So circumference equals pi times d. Diameter is 25, right? So C equals pi times 25, which is the same thing as what? 25 pi. So somebody come back and ask you, what is the circumference of the circle? It's 25 pi. But remember, 25 pi was from here, not just the semi, but the whole thing. So how many holes we got? We got 2 holes. So we had to do 25 pi times what? Times 2. That's going to be 50 pi. Okay, 35. Let's see, 36. We almost there, guys. We are almost there. All right. The system of equations below has multiple solutions, all of which satisfy the equation y equals 4/3 x minus 2. If it can be determined what is the value of a... So if the system of equation has multiple solutions, that means many solutions, which satisfy that equation. System of equations below has multiple solutions, all of which satisfy the equation if it can be determined. So I know many solutions means that what? I know many solutions means you either got the same coefficients, and what? Constants, or we have the what? We have multiples, right? Or same multiples, right? So what I can see is, I don't know if you can see that, if you're going from 8 to 12, that's, well, you go from 12 to 8, that's like, you really could do it that way, or you could do it either way. So to get there, we would do what? 8 times something to give you 12, because it's multiples. It won't be the same coefficients, but it'll be the coefficients in multiples. So 8 times what value would give you 12? Well, we could solve that equation, right, if we wanted to, and divide both sides by 8, because this would be a multiply, we divide, right? It cancels there, so we're left with what? Box, or it's 12 over 8, which reduces to 3 over 2, divide by 5. All right. So then that means that what? You're multiplying all of this by 3 over 2. You multiply the bottom and top. That's what makes it many solutions or multiple solutions. And you checked, you would see that what? If we did 12 over 1 times what? 3 over 2, we should get 18, right? This is 36 over 2, which is 18. You see that? So, whoops. So you see what happens? And if we did what? 8, we already knew that because we did division. But just to show, if we did 8 over 1 times what? 3 over 2, we should get 12. So that's 24 over 2, which is 12, right? So you see, you multiply them by 3 halves, and that's what multiple many solutions mean. The constants and coefficients are either the same or they're in the same multiple. So essentially, all we got to do is we got to add what? We have to add 6 over 1 times what? 3 over 2, which is 18 over 2, which equals 9. That's where A should be. A should be 9. And that would make it many solutions because you took the top and you just multiplied everything by 3 over 2 to get the same as that bottom. That's an example of many solutions. If any one of those numbers off, it would not be many solutions. It would be no solutions or it would be one solution. All right. And lastly, 36. Consecutive terms of an arithmetic sequence have a positive common difference. Arithmetic sequence is when you will add the same number to get, so an example of arithmetic sequence might be what? 1 plus 3 would be what? 4 plus 3 would be what? 7 plus 3 would be 10, 13. You see, we keep adding what? 3. That's an arithmetic sequence. You keep adding or subtracting by the same value to get the next term in the sequence. The sum of the first 3 terms of the sequence is 120. So the first 2 seconds is 120. We don't know the positive difference. Which of the following values cannot be the first term of the arithmetic sequence? So the sum of the first 3 terms of the sequence is 120. So if we add the first 3, it's going to be 120. And it says, which of the following values cannot be the first term of the arithmetic sequence? I know there's a formula for the sum of an arithmetic sequence, and that might be easier to use in this case. If we need a formula, that might be easier to use. Is actually knowing the formula, remembering the formula for the sum. Uh-oh, I'm not gonna run my juice. The sum of an arithmetic sequence. Let me look that up really quickly. Because I can't remember from my head. But there's another way you do it too. Sum of arithmetic sequence formula, right? I don't know if that's gonna work. Because it says sum equals sum of it, arithmetic sequence in whatever term we want over 2. How many ever terms you want, which is 3. With 2 common difference, we know is D. We don't, or the first term. Positive common difference. Some first return the sequence is one term, followed cannot be the first term of sequence. I wonder if we can get it from the formula. So let's take a look at the formula, which is sum of the arithmetic sequence. So the sum of 3 numbers in the sequence is equal to 3 over 2. Well, let's write the generic formula. So we got S of n is equal to 3. I know it's a longer way, but just writing them out. Just want to see what happens. 2a is the first term plus n. We're talking about the nth. Oh no, I'm supposed to be writing this out. Generically speaking, I'm not supposed to be substituting this out. N over 2 to a plus n minus 1 times c. So that's the sum of however many, how many, one we got, wait, is that right? the sum, the number of terms being added. Right, they call it arithmetic series. Wait, why are they giving me different formulas? Oh, there's two different ones? The arithmetic series is some of the arithmetic series. Formula for the arithmetic series. Oh, it's two, all right. You could use two of them. Or you could do what? Well, this one doesn't, one of them doesn't have a common difference. It has the number of terms, the first term, and then whatever term you want. Um, Maybe we could use that one because we could always plug in those first terms. Yeah, we're gonna use that one. We're gonna use the other one that I see here. But that should equal it. That should be good. So if we do S of n is equal to n over 2 a1 plus an, we know we want the sum of the first three terms, which is 3. So S of 3 equals 3 over 2. And then the first term, we don't know. Well, we can substitute plus the nth term, which is the last term. We're definitely not going to know that. But we can plug in those answer choices and see which one of those could it be. 20 plus, we plug in 20, 3 over. I think it's got to be something that you can multiply by 32. I don't think the 39 is going to work. Because if we put 39 there, right, when we distribute that, we're going to get what? I don't think we're going to get a decimal value for the first sum of the sum of the first three. Let's see, so 39, because that's 39 divided. So when we do 39, 3 over 2 times 39, we're not gonna get a whole number. So I'm gonna guess it's probably 39. Because when we plug it in this formula, if we plug in all the other numbers in 20, 24, 30, 44, when we multiply by 3 over 2, we're going to get a whole number. You see that? So, because if we do 3 over 2 times 20, these are going to cancel. We get 1, oh, we get 1, we get 10, and then we get what? That's 30 over 1, which is 30. And then we do 3 over 2 times 24. That's 1, that's 12, that's 36, right? So all of these, and then plus whatever that first term, whatever that last term is. But the 39 is not going to work because when we do 3 over 2 times what? 39, right? We can't cross out the 2 and the 39. So 3 times 39 is what? It's 27, 2, that's 117 over 2. That's going to give you a decimal. 117 divided by 2, whoops. 117 divided by 2, that's going to give you a decimal. That's going to give you 58.5. And then you taking 58.5 plus if you did 3 over, oh no, but 3 over 2 times that, 3 over 2 times that last term could work. Because that's going to give you a decimal too, and the 0.5s together will give you a whole. So I guess it could work. Hmm. All right, so I'm not seeing it that way. Let's try one more way. Um, let's see with this one. So if we had, let's say if the first term was 20 and you add up to 120, um, so we'd have 100 left. So we had 50, so that would be 20 plus 70. Okay, there we go. 20 plus 70. No, plus 50. No, that wouldn't work. Because it has to add up to 1. The numbers have to add up. So if the first term is 20, that means we got 100 left. So our two numbers have to add up to 100. Right? Because the total has to be the sum of the first three terms of the sequence is 120. So when you add all three, we're going to get 120. So that means we got basically two numbers here that should give you 100, but they have to also be equal distance apart. So for instance, let's put, if we did 40 plus what? 6, oh, there it is right there. So that works. Because you see how these are all what? These all follow the geometric sequence. You all are adding what? 20 to both, right? 20 to those. So the common difference is 20. That makes it a arithmetic sequence because you keep adding the same number. And then if we um, add those up, we get 120. So F is gone. So this is the long way we can do it, right? It's probably a shorter way, but let's stick here. So 24 plus A equals 120. Um, so let's see, 120 minus what? 24 equals 96. I'm just guessing, check. If we did 20 again, I don't think that will work, right? It's 20, so that would be 44. So 96 minus 44 would be 52. No, because that would be 54. What about 18? 24 plus 18. It's got to be a faster way. I can't think of it right now. And the common difference. I don't know why I'm not drawing a blank on it. Because every term of the sequence, the sum of this first three terms of the sequence is 120. That would be the 120 part to sum. The first term. Maybe I should substitute that 120 in there. Take sequence. Could I get it done? No, because I didn't know that. No, I did. Well, no, I could have done it that way. Got to go back to what I was doing. I forgot you could have put in. So if we use the formula, I could do it that way. We got S of n equals n over 2 A1 plus AN, right? So we could just plug that in and see what we're getting. So this is going to be 120, the sum of the first, what, three terms. And if the first term is 20, so then we could solve for what, AN, and see what we get. So that would be the last term, right? AN would be the last term. So we get what? 3 over 2 times, so we get 120 equals 3 over 2 times that. That would be 30 plus 3 over 2 AN. Subtract 30, we get what? 90 equals 3 over 2 A to the N. And then you multiply that 90 by 2/3. You would get what? We would get A to the N is equal to, well, we already know. Duh, we already know. So 2/3 of 90 is 60. So last term is 60, that means the middle was 40, but we already checked out. Okay, so that works. So we can do that one. So we just probably just have to use each one in the formula and see what we can come up with, right? So the next one would be what? 120. First three terms. First term is 24 plus A to the N. This is the long way maybe, but nevertheless it works. 320. That's 12, that's 36 plus what? 3 over 2 A to the N. So 120 minus 36. 120 minus 36 equals 84. So we get 84 equals 3 over 2 AN. And then multiply by what? 2/3, or divide by to get rid of that. Right? Divide by 3 over 2 is the same thing as multiply by 2/3. So AN would equal 56. So the first term is 20, and then we'd have three terms. We'd have 24, 24 plus some middle number plus 56. So 56 minus 24. And we got to split that in two. So that'd be divided by two, it'd be 16. So we'd be adding 16 every time. So 24 plus 16 would be 40, right? So that'd be plus 16. And that should equal 120, right? Plus 16, 120. So let's see, will that equal 120? So 24 plus 40 plus 56. Yep, that equals 120. Yeah, that's good. Let's go to 30. Uh-oh, I didn't mean to do that. Right? 30. I think it's still 39. I got a 30. It's gonna be 39 because of the decimal, but let's see. 30. That's 15 times 3 is 45. So we got 120 equals 45 plus 3 over 2a to the n. Subtract 45 from both sides. We get that's going to be 75 is equal to 3 over 2a to the n. We do 2/3 of 75. That's going to be a to the n is equal to 50. So the first term is we got 30 and then plus and then plus. Well, we see that's going to be 40, right? Then that means because that was plus 10 of the arithmetic sequence. So that works. Okay. So it looks like I was probably right with that 39. Right with 39. 39, we said was going to be what? 39, 39 times 3 divided by 2 was 58.5. So we got 120 equals 58.5 plus what? 3 over 2a to the n. Oh yeah, that's going to be a problem. I can see it already. So when we subtract 120 from that, we got 61.5. So we got 61.5 is equal to 3 over 2a to the n. And then if you do 2/3 of that, 41. Or maybe it's not a problem. So that's 41. That a to the n equals 41. So that would be 39 plus 41. So that would mean this would have to be 40. Does that work? Do those three numbers add to 120? 39 plus 40 plus 41? Ha! That wasn't 39. Good thing we tried them all. It's got to be 44. Number must be too big. It's probably what it is. Yeah, because if it's 39, 40, 41, you're not going to have a difference, right? That means that's 39, 40, 41 means that the difference between them is +1. And they said they have a common a positive common difference. So if it's 44, you would have to go down to get to 120. You guys see that? Because I could have really did that in my mind if I was thinking. So because you do 44 plus, and this is a positive common difference, any number greater than 44, let's say if you do 45, then you got to do a third term, 46, right? You're going to go over 120, right? 44 plus 45 plus 46, right? You're going to go 135, right? So even if you do a decimal, right? Because they didn't say it had to be an integer difference. Certain arithmetic you have positive combination. Right. It didn't say it had to be an integer, but even if you did decimals, 40, then you did what? 44.5 and then 45, that still is going to be 44 plus 44.5. Because you're still doing what? That's still a 0.5, right? You added 0.5, you're adding 0.5. That's still going to be 133.5. That's still going to be greater than 120. Right? So because that's going to be 133.5 when you add those three up. Let's see if we can show our equation too. So we know the correct answer is K because it's just too big when you do the positive common difference. If it didn't say positive common difference, if it could have been a negative, because with the arithmetic sequence, you could subtract. You could subtract, right? So if you did something like 44 and then you can go backwards, then maybe this could work. I'm not saying these three work, but let's see, just to give you an idea. So 44 plus 40 plus 36, 120, there it is. So, but this is a negative common difference because this common difference is what? -4, which would be plus -4. And that doesn't work because it's a positive common difference, which means that from the first term, you have to go what? You have to go up. Okay. Wow, that one took a little bit of time, but that's good. You guys get a chance to see a process. Let's see it with the formula too. Let's put 44 in there. That's going to be 2. That's 22 times 3 is 66, right? Plus 66 plus 3 over 2, a sub n. And then we do 120 minus 66. That's 54 equals 3 sub 2, 2, a sub n. Multiply that by 2/3. 54 divided by 3. So that would be 36. So a sub n would be equal to 36. Now that's a problem because what? Because if 44 is the first term, plus then that, then plus then that, then 36, that means that what? This is not a positive common difference. That's a negative common difference because you have to go down. Hope you guys got that. Sorry that that problem took a long time, but I actually think that was good because it helps you to see the processes by which you can go about figuring out what to do and how to do it. I was maybe talking fast, but it's fine because guess what? You can slow down the speed or you can do rewind since this is a video. I hope this was helpful. I think I'm going to work on doing one for reading and English and science because I haven't seen any out on any of those. But I'm going to put the math out because math is typically the one that's hardest for most students. If you guys need any other help or you want some consistent tutoring, feel free to reach out to us. Again, www.actprepchicago.com or reach us at 773-474-2540. Thank you. Bye-bye.